Now I am going to begin second lecture on current electricity, current density. Now here we will begin from current density. Up to now I have explained you about current and what will be the magnitude of current, what will be the direction of flow of current in any conductor. So all these things you have already studied in the lower classes as well as I explained in the previous lecture. Now, what is current density? This is a new term for you. Now, current density is a vector quantity and it is defined as current flowing through unit cross-sectional area at any point. Current flowing through unit cross-sectional area at any point is defined as the current density. Now, I am going to explain you with the help of this diagram. You can see here. Suppose this is any conductor. This is any conductor. Now here current is flowing in this direction. Here direction of current I have marked. Suppose current is flowing in this direction. It's clear. And you have to determine current density at this point. You can see here. Suppose you have to determine current density at this point. So how will you determine the current density at this point? So we will take a unit cross-sectional area around this point. Around this point, we will take a unit cross-sectional area. Or you take a cross-sectional area whose area is A. Here area is A. You can see here. Let me take this again. See here. Suppose you have to determine current density at this. So we will assume a unit cross-sectional area. Here, what is the direction of current? Direction of current is this. So normal to the direction of current, we will take an area A. Here, suppose this is the area A. This cross-sectional area is A. This is normal to the direction of current. You can see here, this area is normal to the direction of current. Current is flowing in this direction. Now, if suppose the magnitude of this current is I, and this area which I have taken, it is A. It is A. Then what will be the current density? It will be I upon A. Now, there is one assumption here that this current is uniformly distributed over the area. It is uniformly distributed over the area. मतलब क्या है? हर एक पॉइंट से सेम अमाउंट ऑफ चार्ज पास हो रहा है. ये ऐसा नहीं है कि ये जो ऊपर वाला सरफेस है उससे अधिक चार्ज पास हो रहा है एंड थ्रू द इंटीरियर लेस चार्ज पास. Here we have assumed that current is uniformly distributed over the area. So what is current density? Current density is defined as the current passing through unit cross-sectional area perpendicular to the direction of current. ये perpendicular to the direction of current ये होना चाहिए. Current passing through unit cross-sectional area perpendicular to the direction of current. Suppose you have to determine current density here. इस पॉइंट पर को फाइंड आउट करनी थी. तो इसके अराउंड हमने एक क्रॉस सेक्शनल एरिया ए ले लिया. सपोज थ्रू दैट क्रॉस सेक्शनल एरिया हाउ मच करंट इज पासिंग I, then current density is defined as I upon E. Now one more thing, if you take the conductor of uneven shape, here this is a conductor of uneven shape. So already I have told that if a conductor of uneven shape, then in that magnitude of current will remain same. जो current इस cross sectional area पर होगी उतनी ही current इस cross sectional area पर होगी. मतलब कहने का मतलब क्या है कि पर सेकंड जितना चार्ज यहाँ से फ्लो होगा पर सेकंड उतना ही चार्ज यहाँ से भी फ्लो Now if you see here, which cross sectional area is more? So here cross sectional area X is having more area and Y is having less area. So at which point current density will be more? So you can find out here. I दोनों जगह पर क्या है? सेम है. एक इसका कम है. Age area is less for cross section Y. Therefore, current density at point Y at the cross section Y will be more than the current density at cross section X. मतलब क्रॉस सेक्शन Y पर करंट डेंसिटी का वैल्यू अधिक होगा और क्रॉस सेक्शन X पर करंट डेंसिटी का वैल्यू लेस होगा. Means current density depends upon the area of cross section. It's clear. That's why we say that the current density is a microscopic property of current carrying conductor. Microscopic. Current क्या है? It is the macroscopic. MACR. Macroscopic. Current कैसी property है? Macroscopic. MACR. While the current density, it is microscopic. Means MICRO. It's clear. So it may be different at the different points of cross section. It may be different at the different point of the conductor. And if the current is distributed uniformly over the cross section. It's clear. Here we have assumed that current is distributed uniformly. इसीलिए क्या है? ये क्या है? सपोज ये कंडक्टर है, उसका ये क्रॉस सेक्शन है. इस क्रॉस सेक्शन के हम इस पॉइंट पर करंट डेंसिटी निकालें, इस पॉइंट पर करंट डेंसिटी निकालें, दोनों जगह क्या आएगी? सेम आएगी. क्योंकि हमने ऑलरेडी एज्यूम किया है यहाँ पर दैट द करंट इज डिस्ट्रीब्यूटेड यूनिफॉर्मली थ्रू आउट द क्रॉस सेक्शन. क्लियर. सो जो करंट डेंसिटी की वैल्यू इस क्रॉस सेक्शन के एक पॉइंट पर आएगी, वही करंट डेंसिटी की वैल्यू यहाँ पर भी आएगी, वही करंट डेंसिटी की वैल्यू यहाँ पर भी आएगी. ये ऐसा नहीं है कि अलग अलग हो. क्लियर. For our course, we assume that current density is uniform at every point of the same cross section. किसी भी क्रॉस सेक्शन के डिफरेंट पॉइंट्स पर करंट डेंसिटी यूनिफॉर्म होगी. एक्चुअल में ऐसा नहीं होता. एक्चुअल में ऐसा नहीं होता. It's clear. So, but here for our sake, we have assumed that current is distributed uniformly over the area A. Therefore, current density at every point will remain same. So, what is the first point in this topic? You can see once again, what is current density? Current density at any point of the current carrying conductor. It is defined as the current passing through unit cross-sectional area perpendicular to the direction of current. This is the first point. It's clear. If we assume that current is distributed uniformly over the area A, then current density is given by J equals to I upon A. It's clear. Then current density at different points of the same cross-section. जो करंट डेंसिटी की वैल्यू होगी एट द डिफरेंट पॉइंट्स ऑफ द सेम क्रॉस सेक्शन दैट विल बी सेम. ये यहाँ पर ठीक नहीं बना है, इसको फिर से बना देते हैं. ये एक क्रॉस सेक्शन है, इसके डिफरेंट पॉइंट्स पर अगर हम करंट डेंसिटी की वैल्यू फाइंड आउट करें दैट विल बी सेम. जो करंट डेंसिटी की वैल्यू यहाँ पर आएगी वही क्या आएगी, यहाँ पर आएगी, वही क्या है तीसरे पॉइंट पर आएगी. इट्स क्लियर. बट it may be different at the different points of the conductor depending upon the area of cross section. क्लियर. अगर अनइवन थिकनेस का कंडक्टर है, सो जहां पर वाइडर क्रॉस सेक्शन है वहां पर करंट डेंसिटी विल बी लेस एंड here it will be more because the cross sectional area is less. It's clear. So these things I have explained. Now what will be the unit of current density? So it is ampere upon meter square. Ampere upon meter square. Now one more thing, current density is a vector quantity. What will be the direction of current density? So direction of current density will be in the direction of current. It will be in the direction of current. Now see here, let's see in the next slide. Here it is a vector quantity, its direction will be in the direction of current. It's clear. Current density is a vector quantity, its direction at any point will be in the direction of flow of positive charge. Flow of positive charge वही होती है जो direction of current होती है. Now SI unit of current density I upon A ampere per meter square, dimensional formula. This is very simple thing that you can determine. Then current density is the characteristic property of any point. It may have different values at the different point of conductor. That's why we call it as a microscopic quantity. जबकि करंट के लिए हमने क्या बताया, इट इज ए फंडामेंटल प्रॉपर्टी फॉर होल कंडक्टर. It is fundamental property. It will be same at every point of the current carrying conductor. Yes, same. It's clear. Now one more thing. Here you can see, suppose this is a conductor, and here we have taken the cross-sectional area. Yes. Cross-sectional area हमने क्या लिया? Yes. थोड़ा इसको से नहीं बन रहा है, इससे बना. This is the cross-sectional area. It's clear. Means it is not perpendicular to length. And what is the current? Current is this. This is the direction of flow of current. देख लो करंट की डायरेक्शन ये है, मींस करंट डेंसिटी की भी डायरेक्शन क्या होगी? करंट डेंसिटी की भी डायरेक्शन यही होगी. करंट डेंसिटी ऑलरेडी आई हैव टोल्ड दैट इट इज ए वेक्टर क्वांटिटी in the direction of current. Now what will be the area vector here? So area vector, you can see that area vector will be in this direction. It is normal to the area. It is normal to the area. Means area vector is this. Whether it is clear? This is the area vector. So how much current will pass through this cross section? अगर हम ये पूछे कि इस क्रॉस सेक्शन से कितनी करंट पास होगी, सो एज यू नो दैट J इज डिफाइंड एज I अपॉन A. J को कैसे डिफाइन किया है? इट इज I अपॉन. सो व्हाट विल बी I? I will be equal to vector J dot vector A. Vector J dot vector J dot vector A. There will be a scalar product between the current density vector and area vector. It's clear? Current density vector or area vector का scalar product will give the current passing through that cross section. In case if this is like this, cross section तुम्हारा ऐसे है, in that case what will be? I will become simply J into A. तब क्या हो जाएगा? I क्या हो जाएगा? J into A हो जाएगा. क्यों J into A हो जाएगा? Because vector J and vector A will be in the same direction, and when they will be in the same direction, what will vector J dot vector A? It will be J A cos 0 degree. ये angle क्या हो जाएगा? 0 हो जाएगा. It's clear? So this is one more thing. It is clear? Now see here. So this I have defined, explained already. Then Now I am going to explain mechanism of flow of current in a metallic conductor. Already I have told many points of this in the lecture 1. This you can see here. In metallic conductor, current is constituted by the free electrons, whose concentration in it is huge. Means concentration free electrons का बहुत होता है. Concentration means free electron density, जिसको किस सिंबल से डिनोट करते हैं, स्मॉल एन से. Number of free electrons per unit volume. So in silver, free electron density 10 to the power 29 per meter cube. 10 to the power 29 per meter cube. While in the gold, in the aluminum, in the copper, it is how much? 10 to the power 24 per meter cube. That's why silver is considered as the best conductor, and copper, gold, aluminum, they are considered as the good conductor. Already we know that at room temperature, these free electrons move randomly within the conductor because of the temperature of the conductor. Because of the temperature of the conductor, they move randomly. Randomly means like this. They are moving like this. Therefore, what will happen? They will not constitute any current. कोई भी करंट ये constitute नहीं करेंगे. क्यों? Because overall average thermal velocity will be 0. इनकी average thermal velocity क्या हो जाएगी? 0 हो जाएगी. Here thermal velocity of this free electron is U1. Thermal velocity means it is the velocity acquired by the free electron because of the temperature of the conductor. इस कंडक्टर के टेम्परेचर के कारण इलेक्ट्रॉन्स जिस वेलोसिटी से ट्रेवल कर रहे हैं, दैट इज कॉल्ड द थर्मल वेलोसिटी. क्योंकि उस वेलोसिटी का सोर्स क्या है, उसके लिए एनर्जी कहां से मिलती है? इसकी जो हीट एनर्जी है, इसकी जो थर्मल एनर्जी है. More the temperature, more will be the thermal energy possessed by this conductor, and more will be the thermal velocity of free electrons. So इंडिविजुअल इलेक्ट्रॉन्स की सपोज थर्मल वेलोसिटी इसकी क्या है? U1 है, इसकी U2 है, इसकी U3 है, इसकी U4 है. अगर हम सबका क्या करें, एवरेज निकालें. इट्स क्लियर. सो व्हाट विल बी द एवरेज थर्मल वेलोसिटी? Average thermal velocity will come out 0. You can see here. Here, if you find out the average thermal velocity, then it will be 0. Here we will do the vector sum of the thermal velocity of all the free electrons present in the conductor. कंडक्टर में जितने फ्री इलेक्ट्रॉन्स प्रेजेंट है, सपोज ये एक कंडक्टर है, दिस इज एनी कंडक्टर, इसका एक क्रॉस सेक्शनल एरिया, ये क्या है, एक एनडीए है, एक दूसरा एनडीए. इस पूरे कंडक्टर के अंदर सपोज कितने फ्री इलेक्ट्रॉन्स प्रेजेंट हैं? कैपिटल एन. कैपिटल एन इज नॉट फ्री इलेक्ट्रॉन डेंसिटी. कैपिटल एन इसकी फ्री इलेक्ट्रॉन डेंसिटी नहीं है. कैपिटल एन क्या है? नंबर ऑफ फ्री इलेक्ट्रॉन्स प्रेजेंट इन दिस कंडक्टर. इट्स क्लियर. So suppose their thermal velocities are vector U1, vector U2, vector U3, and so on, vector UN. Then what will be the sum of their thermal velocity? It will be equal to this. Vector U1 plus vector U2 plus vector U3 plus and so on plus vector UN. So in order to find average, we will divide by n. It will come out 0. ये 0 क्यों होगी? Because we already know that thermal motion do not constitute any electric current. Thermal motion of free electrons do not constitute any electric current means जो एवरेज थर्मल मोशन फ्री इलेक्ट्रॉन्स का है वो क्या है? 0 है. एवरेज थर्मल मोशन फ्री इलेक्ट्रॉन्स का 0 है, मतलब क्या है? उनकी थर्मल वेलोसिटी क्या है? एवरेज थर्मल वेलोसिटी क्या है? 0 है. Second point I have explained about the electron gas. Since the motion of free electrons within the conductor is just like the motion of the molecules in a enclosed vessel, that's why it is said that free electrons within the conductor constitutes an electron gas and their motion मतलब free electrons का motion will be governed by the gas large मतलब गैस लार्ज से ही उनका मोशन गवर्न होगा अगर हम इनकी आरएमएस वेलोसिटी अगर इन फ्री इलेक्ट्रॉन्स की आरएमएस वेलोसिटी आरएमएस मींस रूट मीन स्क्वायर इट्स क्लियर if we assume that the rms velocity is vrms so as you increase its temperature ये वैल्यू की क्या हो जाएगी बढ़ जाएगी this value will also increase so take this now see here so within a conductor these free electrons are moving randomly you can see here what is the magnitude of their thermal velocity so magnitude of the thermal velocity 10 to the power 5 meter per second these things already I explained in the lecture 1 because of the random thermal motion of free electrons no net current is produced why because the current produced by one electron will be neutralized by the other electron it's clear now see here there are two terms mean free path and average relaxation time now what is mean free path and average relaxation time so see here what happens here you can see in this slide I'm going to show you when a potential difference is applied suppose this here when you will apply some potential difference हमने एक बैटरी से इसके एंड्स को कनेक्ट कर दिया दिस इंडिकेट लो पोटेंशियल ये लो पोटेंशियल पर है and this is at high potential now what will happen an electric field will be developed all across the length of the conductor उस इलेक्ट्रिक फील्ड की डायरेक्शन क्या होती है इलेक्ट्रिक फील्ड की डायरेक्शन क्या होगी हाई पोटेंशियल से लो पोटेंशियल an electric field will be developed all across the length of the conductor उस इलेक्ट्रिक फील्ड का मैग्नीट्यूड क्या होगा अगर इस कंडक्टर की लेंथ हम क्या ले लें एल ले लें कि इसकी लेंथ कितनी है एल है और ये पोटेंशियल डिफरेंस कितना है बी है तो उस इलेक्ट्रिक फील्ड का मैग्नीट्यूड क्या होगा इलेक्ट्रिक फील्ड सबको मालूम है इट इज इक्वल टू पोटेंशियल ग्रेडियंट potential drop per unit length. It's clear. If its length of the conductor is capital L and potential difference applied across the ends is capital V, then what will be the electric field? It will be this. Now, what will be the direction of electric field? It is from high potential to low potential. Now, as we know that due to this, what will happen? Electron will start experiencing an electric force और उस इलेक्ट्रिक फोर्स का मैग्नीट्यूड कितना हो जाएगा तो मैग्नीट्यूड कितना होगा यू कैन सी हियर अगर Q चार्ज E इलेक्ट्रिक फील्ड में रखा है तो उस पर कितना फोर्स लगता है Q इंटू E इलेक्ट्रॉन पर चार्ज कितना होता है स्मॉल ई कितनी इलेक्ट्रिक फील्ड में रखा है कैपिटल ई सो इलेक्ट्रॉन पर कितना फोर्स लगेगा स्मॉल ई इंटू कैपिटल ई स्मॉल ई क्या है it is the charge on one electron what will be the direction of this force so direction of this force will be opposite to the electric field मतलब ये जो फोर्स लगेगा वो किस डायरेक्शन में लगेगा it will act in this direction जिस डायरेक्शन में इलेक्ट्रिक फील्ड की डायरेक्शन है उसके अपोजिट now because of this force free electrons will start accelerating free electrons क्या है एक्सीलरेट करें but they will not accelerate continuously they will not accelerate continuously मतलब ऐसा नहीं होगा कि उनकी वेलोसिटी लगातार बढ़ती जाए और ऐसा क्यों नहीं होगा because they have to pass through small vacant spaces between the positive ions. Electrons have to pass through small vacant spaces between the positive ions. And when they pass through vacant spaces, what will happen? They will be attracted by the positive ions. Means their collision will take place with the positive ions. मतलब क्या होगा? जब इलेक्ट्रॉन्स फ्री इलेक्ट्रॉन्स एक्सीलरेट करते हैं, they suffer collision with the positive ions. During the collision, they lose their energy and come to momentarily at rest. Momentarily at rest means for a moment. केवल एक मोमेंट के लिए वो रेस्ट करते हैं, बिकॉज द फोर्स इज स्टिल एक्टिंग. फोर्स तो अभी भी एक्ट कर रहा है. क्यों फोर्स अभी भी एक्ट कर रहा है? क्योंकि इलेक्ट्रिक फील्ड बनी हुई है. देयरफॉर फोर्स इज स्टिल एक्टिंग. देयरफॉर वंस अगेन दे विल एक्सीलरेट. फिर से वो एक्सीलरेट करेंगे. वंस अगेन दे विल सफर कोलिजन विद द पॉजिटिव आयंस, loses their entire energy and come to rest. मतलब क्या होगा? When you will apply the potential difference, then an electric field will be developed all across the length of the conductor, directed from where to where? High potential to low potential. Due to this electric field, which is given by this, due to this electric field, all the free electrons will experience this force. What will be the direction of this force? Opposite to electric field. Now, due to this force, they will accelerate towards the higher potential, but they will not accelerate continuously. Why? Because when they accelerate, they pass through the vacant spaces between the positive ions. During this, they will suffer collision with the positive ions, and in these collision, they lose their entire energy and come momentarily at rest. But due to the existing potential difference, what will happen? Once again, they will accelerate. फिर से वो accelerate करेंगे. Once again, they will suffer collision with the positive ions and come to momentarily at rest. Therefore, this process will take place again and again for all the free electrons. सभी free electrons के साथ यही होगा बार बार. So instead of acquiring a continuously increasing velocity, what will happen? They will acquire a constant average velocity. It's clear? They will acquire a constant average velocity. मतलब उनकी velocity लगातार नहीं बढ़ेगी. क्यों? क्योंकि in between क्या हो जाते हैं? Collisions हो जाते हैं. So there is one term, mean free path. It is the average distance traveled by the free electron during two successive collisions. The free electron move at random with sufficiently high velocity in the vacant spaces between the positive ions. During motion, the free electron collide with these ions again and again, and after each collision, their direction of motion change. उनकी direction of motion क्या हो जाती है? Change हो जाती है. The average distance moved by the free electron between two successive collisions is called the mean free path. इसके free path क्या है? It is the distance traveled by a free electron in between two successive collisions. But this distance may be different for the different electrons. Therefore, we find out the average distance. And this average distance, it depends upon the packing of atoms within the conductor. कि कंडक्टर के अंदर एटम्स कितनी क्लोजली स्पेस्ड है. अगर बहुत ही क्लोज है, then what will happen? Collisions will be frequent, mean free path will be less. But if atoms are apart from each other, then what will happen? Collisions will be less frequent, mean free path will be longer. It's clear? So see here, average distance moved by a free electron between two successive collisions is called mean free path. And there is one term, relaxation time. It is the average time spent in between two successive collisions. मतलब एक collision के बाद इलेक्ट्रॉन का दूसरा collision कितने टाइम बाद होता है, that is called the relaxation time. It's clear. Average time is spent in between two successive collisions of free electron with the positive ions. That is called the relaxation time. And this relaxation time is represented by the symbol tau. Mean free path is represented by the symbol lambda. So what will be tau? Tau equals to lambda upon VRMS, where VRMS is what? RMS velocity of free electrons. It is the RMS velocity of free electrons. Then there is one term, drift velocity. What is drift velocity? So you can see here. This already I explained. जब पोटेंशियल डिफरेंस लगाएंगे तो क्या होगा ये हमने ऑलरेडी बताया है. Free electrons will start moving from low potential to the high potential. These things already I explained. An electric field is developed, motion of free electrons in a conductor when a potential difference is applied across its cells. An electric field is developed all along the length of conductor. मतलब जब हम potential difference लगाते हैं तो क्या हो जाता है? एक इलेक्ट्रिक फील्ड डेवलप हो जाती है all along the length of conductor. कहां से कहां डायरेक्टेड होगी? फ्रॉम हाई पोटेंशियल टू लो पोटेंशियल. Because of this electric field, an electric force will set up on the free electron, which is given by this already I explained. Where capital E is what? Capital V upon the length of the conductor. Capital V is potential difference. Due to this force, free electron get accelerated towards the higher potential for a time interval is spent in between two successive collisions. For that time interval, they will accelerate. After this time, what will happen? They will suffer collision with the positive ions. And when they will suffer collision with the positive ions, you can see here, when they will suffer collision with the positive ions, they will come at momentarily at rest. मतलब केवल एक क्षण भर के लिए रेस्ट में आ जाएगी due to losing of full energy. But due to existing potential difference, once again they will accelerate, suffer collision with the positive ions, loses their entire energy and come to momentarily at rest. This process takes place again and again and for all the free electrons. सभी इलेक्ट्रॉन्स के लिए होगा और बार बार होगा. It's clear? ये ऐसा नहीं कि कुछ के लिए. Therefore, instead of acquiring a continuous increasing velocity, they acquire a constant average velocity, which is called the drift velocity. This velocity is called the drift velocity. What is the drift velocity? You can see here. It is the constant average velocity acquired. Constant word होना ही होना चाहिए. It's clear. Constant average velocity acquired by the free electron under the influence of potential difference across the ends of conductor. What is the magnitude? 10 की power minus 4 meter per second. Means 0.1 millimeter per second. Now, what will be its direction? It is directed towards the higher potential. क्योंकि free electron कहाँ से कहाँ जाते हैं? Low potential से high potential. So this is all about the drift velocity. It's clear. So you can go through these slides. This is drift velocity. Showing once again from the beginning. Current density. Then this is also about current density unit. It is a vector quantity. It is the characteristic property of a point. Then it is about the mechanism of flow of current in a metallic conductor. Mechanism of flow of current. Average thermal velocity of all the free electrons will be 0 because the thermal motion do not constitute any electric current. Then electron gas, this I explained. Then mean free path and relaxation time. This is the definition of mean free path and relaxation time on this page. Then Here, motion of free electron in a conductor, this I explained under the influence of potential difference. And this is the drift velocity. ये क्या था? Drift. So this is all about in this lecture. In the next lecture, I will begin from the mobility of electrons.